Right, in lesson number 7, Mr. Simons will be looking at double angles. We'll introduce you to that, and we're going to derive the formula for all the double angles, right? Now, when we say double angle, we simply mean any angle that's multiplied by the value 2. So we have 2 times the angle, it's referred to as a double angle. So in this first problem, we're going to derive the formula for sine 2a, or double angle of a. So sine 2a can be written as sine a plus a. If we use compound angles, I assume you remember that would become sine a cos a plus this plus cos a sine a, right? Now, if we rewrite them, that is 1 sine a cos a, invisible 1. There I'm just moving sine a to the front, cos a. So you see it's like terms. So 1 plus 1 gives me 2 sine a cos a. So sine double angle will always expand to become 2 sine a cos a. Right? Now we're going to be looking at cos double angle. Right, now to derive the formula for cos 2a again, I'm just going to say cos 2a equal cos a plus a. Right, and expanding that using compound angles, I assume you remember, becomes cos a times cos a plus becomes minus sine a sine a. Cos times cos gives me cos squared a, and sine a times sine a gives me sine squared a. So cos double angle becomes cos squared a minus sine squared a, but it still has another 2 parts to it. Right, so that's what we're going to be looking at in the next problem. So I hope you follow and understand so far what I've done. Alright, now deriving the other formulas for cos 2a. First and foremost, in grade 10, you introduced to the square identity, so you should know sine squared a plus cos squared a equal 1. Right, now we can rewrite this. If I take cos squared a over, it becomes 1 minus cos squared a, so sine squared a equal 1 minus cos squared a. Or if I take sine squared over, that becomes cos squared a equal 1 minus sine squared a. So using this, we can create 2 other formulas, right? So cos 2a is cos squared a minus sine squared a, but I know sine squared a equal 1 minus cos squared a from my square identity. So in the place of sine squared a, I place 1 minus cos squared a. So that becomes cos squared a minus times 1. Negative times 1 gives me negative 1. Negative times negative, positive cos squared a. So cos squared a plus cos squared a then gives me 2 cos squared a minus 1. So cos 2a can also be expanded as 2 cos squared a minus 1. In the next one, we're just going to substitute cos squared a. Alright, so for the fourth one, cos 2a equal cos squared a minus sine squared a. But cos squared a equal 1 minus sine squared a. So in the place of cos squared a, I put 1 minus sine squared a minus sine squared a. Minus sine squared a minus sine squared a gives me minus 2 sine squared a. So cos 2a equal 1 minus 2 sine squared a. So that in short is my double angles and their expansions I've derived. We can test this in exam. It's one of your exam questions. Hope you understand. I wish you nothing but the best. Alright, persevere. You're in grade 12 now. Show them what you're made of.